Today, heavy-duty autonomous machines roll across vast American fields with almost zero human intervention. But 3 centuries ago, every single acre of North American soil had to be worked by human hands. This leap in scale reveals a consistent theme in the national story: the effort to solve the physical constraints of the land as a prerequisite for economic growth. Long before European settlement, indigenous tribes established a baseline for cultivation. They relied on a sophisticated companion planting technique known as the Three Sisters, specifically integrating corn, beans, and squash. Later, early U.S. leaders like George Washington and Thomas Jefferson looked at the fertile soil and saw political strategy. They argued that true economic independence would come from cultivating crops locally rather than relying on the established manufacturing centers of Europe. But the young republic immediately hit a bottleneck. As long as the vast majority of citizens were tied to manual, subsistence labor just to grow enough food to survive, the nation had little capacity to expand its borders or its economy. To scale up and develop geopolitical influence, the country had to grow its food supply faster than its population. That requirement drove a relentless push toward mechanical innovation. By the 1800s, government policies like the Homestead Act unleashed a wave of migration, opening up millions of acres of soil across the Midwest and Great Plains. This created an immense logistical problem. The newly acquired territories were too large for traditional farmers, relying on hand tools to plow and harvest at the speed required for a growing nation. The solution arrived in steel and steam. The invention of the steel plow, the mechanical reaper, and eventually steam-powered tractors allowed a single farmer to increase their daily output exponentially. At the same time, expanding railroad networks linked these isolated western fields directly to eastern urban centers. Crop cultivation transitioned from local survival into a profitable nationwide business. Industrializing the farm solved the labor shortage and allowed for expansion across the continent. However, this shift treated the land like a factory, detaching agricultural production from its ecological boundaries. In the 1930s, decades of mechanical expansion collided with a prolonged, severe drought. This diagram shows exactly how the disaster unfolded underground. Heavy industrial plows had ripped up the deep-rooted native prairie grasses. In their place, farmers planted shallow-rooted cash crops that quickly dried out, turning the vital topsoil into loose dust. Without the deep root systems to anchor the earth, high winds weaponized the loose soil and stripped the ground bare. Millions of acres of once fertile farmland were destroyed in these rolling black blizzards, sparking a mass migration of families fleeing westward. Occurring alongside the Great Depression, this agricultural collapse exacted a devastating human toll, leaving millions destitute and hungry. The 1930s demonstrated that industrial production has an ecological breaking point. Ignoring the biology of the land creates a vulnerability that mechanical innovation alone cannot solve. After World War II, the strategy shifted. To avoid another ecological catastrophe, the industry could no longer rely on plowing more virgin land. Instead, it had to increase the yield on the acreage already in use. This was achieved through a scientific shift: the introduction of chemical fertilizers, advanced irrigation systems, and genetic crop improvements pushed per-acre productivity to historic highs. Today, the industry must produce enough food to support a global population and maintain a massive export economy, actively avoiding the mistakes of the 1930s. The current solution to this is precision farming, a method that merges massive digital data processing directly with physical land management. This interface shows the constellation map inside a modern tractor cab. AI uses real-time satellite tracking to map the exact geographic coordinates. That live satellite data micro-adjusts the tractor's speed, optimizing seeds dropped into every inch of soil. From early subsistence to modern precision systems, the evolution of the American farm has turned the challenge of feeding a population into a primary source of global economic influence.